Dear students, let us discuss the sp hybridization. Sp hybridization is due to intermixing of one s orbital and one p orbital. So finally it gives 1 plus 1 2 s and p. So two sp hybrid orbitals. Two sp hybrid orbitals. This is s orbital, this is p orbital, and these are the one sp hybrid orbital, and this is the other sp hybrid orbitals. So s orbital spherical in shape, p orbital dumbbell in shape, combined together a newly shaped hybrid orbital. This is sp hybrid orbital. This is also sp hybrid. 1 plus 1 2 sp hybrid orbitals are there. Now these hybrid orbitals aligned in such a way that there is a minimum repulsion, as valential electron pair repulsion theory. So they align such a way that there are minimum repulsions between the electron pairs in its valential. Means electron pairs means either it is a lone pair or bond pair. So these hybrid orbitals are aligned, aligned with a minimum repulsion between the electron pairs in the valence shell. So let us discuss this sp hybridization with an example: beryllium, formation of beryllium chloride. So in beryllium chloride, the Be is a symbol of beryllium. Its atomic number is 4. Its ground size configuration is 1s2 2s2. Means there are no electrons in the 2p. So now one electron jumps from 2s to 2p. That is nothing but due to excitation. So the excited state electronic configuration is 1s2 2s1 2p1. So there are two unpaired electrons are there in the valence shell or cell of beryllium. So these two valence electrons are there. Now what happened? These two electrons are undergo hybridization. Means what? This is an unpaired electron in s orbital. This is an unpaired electron in p orbital. This unpaired electron in this s orbital, this p orbital undergo intermixing together. Nearly a smaller amount of energy in 2s than the 2p. So 2s is slightly lesser energy than the 2p. So they intermix together. Means hybridization is happened. After intermixing, what happened? 1, 2, 3, 4 hybrid orbitals are formed. In that, how many electrons are there? 2 electrons are there. These 2 electrons are redistributed as per the Hund's rule. So means all they have to fill it with 1 electron, then pairing takes place. So this is 1 electron in sp and this is 1 electron in sp. These two are the empty hybrid orbitals. Right. So now what happened? This beryllium is coming paired with what? Chlorine. So already we know that the chlorine atomic number is 17 and its configuration is 1s2 2s2 2p6 3s2 3p5, and there is an unpaired electron in the outermost shell. Be careful that these two should be opposite in spin. Beryllium, two hybrid orbitals like here, sp hybrid orbital of 1, another sp hybrid orbital, another sp hybrids are like so. They combined with the p orbital, pz. This is the pz, p orbital of chlorine with one chlorine and p orbital of the other chlorine. Means what? This bond is happened along the internuclear axis. Therefore this is a sigma bond of what? This is sp and this is pz, sigma of sp pz, and here is also the relation is formed, and here is this is of pz and this is of sp hybrid orbital. So there is a sigma bond, means sharing along the internuclear orbital, overlapping along the internuclear axis. So sigma sp pz. So totally there are two sigma bonds are there. So one with this chlorine, another with this chlorine. So and now what happened? As you know that the repulsion should be minimum between the electron pairs. So this is an electron pair, bonded electron pair. This is the bonded electron pair. So these are repulsion. Means minimum repulsion means that should be existed at an angle 180 degrees. Therefore, angle between beryllium chlorine and beryllium chlorine is how much? 180 degrees. Therefore, shape is what? Linear in shape. So in a beryllium chloride, there are two sigma bonds are there. Two are of type sp and p. This is the way in which beryllium chloride is formed. Again, beryllium chloride beryllium atomic number 4, its excitation, after excitation it undergo hybridization. There are two hybrid orbitals are there. They align like so and pair with the two chlorines and form two sigma bonds of spp type, and they aligned at an angle 180 degrees. Therefore it has a linear structure. Thank you.